Hello, everyone.
Good morning.
Good morning. Yeah, good morning. Okay. Okay, let me try to share the screen first.
So this is a quick question for you and potentially for all the other students.
Mm-hmm.
So if you didn't really feel about all of your answers on the homework, is there going to be like a key for that so we can know what we got right or wrong?
Oh, you mean the sample answers, right?
Yeah, because I'm still not entirely sure about the ratios or formulas that I used.
Definitely, yeah, the sample answer definitely will be posted. But I think I would first ask the TA to grade some, right? Because sometimes if there is some problem, confuse everyone, we may want to adjust the answer or something, right? But definitely we will post the sample answer, and you can check to try to see if the question is wrong or answer is wrong, right? And if nothing confuse you, we will use that as a standard formula for the test or exam, okay? But no worry, the sample answer will be posted, yeah.
Okay, thank you.
Okay, you're welcome, yeah. So I believe you should be able to see my screen now, right?
Yeah.
Hey, yeah, then we should start our class today. Um, so I think last lecture we ended up in caching system, right? For the web or server cache, for especially for the web cache, right? Proxy servers. The reason for that is we want to reduce the responsible time for client request, especially we have some limited access link, right? So we use example to demonstrate that. I like this example. I think this is a very cool example. Give you some idea if you have a very not very slow but have kind of slow, right? The access link um, between your institutional network, for example, our university network and the public and internet, right? And if the access link is not very fast, how should we deal with this problem? But before that, we need to first understand if the link is slow, what is the responsible time if you the web server web client send a request, right? The key issue here or key thing here is that if you have a lot of users or clients simultaneously send their requests, right, or the web request or the HTTP request, right? Um, the we can calculate, for example, in this case, we can calculate the average data rate to browser, right? Uh, Divide by the access link, that is access link utilization, right? In this case, it's a more than 90%. So still remember that curve. So if the traffic intensity is close to one, that means the average delay would be very high, right? So let's assume the access link delay would be some minutes, okay? And the RTT responsible time, transfer time, right, would be 2 seconds, right? This is our assumption. So generally speaking, our bottleneck would be access link delay, okay? And if we want to solve this problem, one solution is to just upgrade your access link rate, right? By replacing some, by using some upgraded link that will cost a lot of money and also ask you, we need to upgrade our infrastructure, right? So this could be a solution, but may not be optimal solution, right? During the same time, for example, we can upgrade the access link rate by 10 times, but during the same time, we can use caching, right? Caching uh, web server, right, in our institutional network. So the idea is that we just add a local web cache server here. And for example, if we assume that we have 40% of the requests that can be satisfied at cache, 60% of the requests cannot be satisfied. So those requests have to be sent to the original web server, right? And then we can calculate some expected or average, right, end-to-end delay. So we use the 60% times the original delay, right? Because 60% of requests cannot be satisfied at the local web cache. It has to be sent to the original server, right? So we can calculate the expected end-to-end delay using the original delay and the delay if it can be satisfied at the cache. Okay, so the key idea here, if the request can be satisfied at cache, then the delay would be very small because it's local, right? And the institutional network access is is I can say very high because compared to the link to the public internet, 1.5 megabit per second, we have almost 1 gigabit per second LAN, right, in the institutional network. So let's say this is very high, and the very high LAN would provide a very small or almost negligible delay here, right, like some millisecond. Okay, so the overall delay would be still dominated by the 60% of the requests that cannot be satisfied at the cache. Okay, so overall, we can calculate a number. For example, here is a 1.2 seconds, right? If we are using the cache. Okay, so you can see compared to original some minutes, that's definitely a huge improvement, right? But if we compare to upgrade to a solution that upgrade the access link, um, that's also good, right? Remember the previous slides, if we just simply upgrade, that would be also some second. And now we still, right, have some 1.2 seconds, even less, right? So this solution can provide some comparable solution as upgrading the link from 1.5 megabits to 150 megabits, right? So that's a very good and good solution because it's cheaper and we don't need to upgrade the access link, the infrastructure, right? We just need to put a local web cache. But here, the problem is that you have to make sure the request um, can be satisfied at your local web cache is not a very small percentage, right? So here our assumption is 40% can be satisfied. Okay, so that means if you want to access some website, this website is not very frequently updated, right? But I think this is a very reasonable assumption, right? You cannot assume that for example, our university students want to access some general website. That website is updated every day, every hour, right? That's not a reasonable assumption. So I think local web cache is a kind of cool solution to solve this low access link problem. Okay, so that's something we quickly review for what we mentioned in the end of last lecture. Yes, I think WSU network is 10 gigabits per second, and some of the research connection is 40. Yes, I think 10 gigabits per second connection is just as I show, I think several weeks ago, right? I show HPC center connection with institutional network, right? Most of the university are now are commonly using the 10 gigabits connection, Ethernet or some connection, right? And some research connection in the, for example, HPC center, that could be 40 gigabits per second, or even um, internal network could be 100 gigabits per second, right? So yeah, that's a very good infrastructure. Okay, so let's see conditional get. So we have understand the we already understand the cache web cache system, right? And how to make the still remember we are talking about the HTTP protocol, right? How to make that protocol working with the cache system. So we have to have some conditional get. It's not difficult to understand, right? Conditional get, like if this web uh, or HTML file or URL, whatever, is cached in the local server, right? Then the HTTP request do not need to go to the original web server, right? Can be cached here. So we have to have some command. Still remember the command get, delete, update, right? So that's kind of the commands. So here we need to have some conditional get, right? So the conditional get is a HTTP request message if modified since some date, right? Object not modified before some date. So you just try to understand when the object has been updated or not, right? If the server responds at 304 not modified, that means this object hasn't been modified since the date you ask, right? And if it satisfy your condition, that's fine. You don't need to go to the original server, right? After that, you just directly get the data, okay? So this like a conditional get to deal with the cache web caching system, okay? But from a high level principle, it's just like you have some local buffer, right? In computer system, you may often hear the concept buffer, right? Caching, some similar thing, right? Just to make sure the data do not need to move very frequently. Sometimes it can be directly grabbed here or there, right? Do not need to go to the original page. That's some system concept. You may have already noticed that, okay? So I think that's it, the HTTP protocol we talk about for the, I think, the last 2 or 3 lectures, right? So this is the beginning of the application level protocol. This is very important and almost you are using every day, right? So I hope you can understand most of the concept here, right? From um, different from the HTTP request message format to response message format, and how send that request, and persistent HTTP or non-persistent HTTP, right? So those are some important concepts you should remember, okay? So that's HTTP thing. So um, we we will go to the next, but before that, if you have any question we want to discuss, we can discuss. Okay, just feel free to put into the chat. I will notice that, and then I will try to answer. Okay. And the next thing is email or SMTP, IMAP, right? So you can see from the title, the web, it's a main function you want to use. HTTP is its protocol. So here, the email is something we want to use, and its protocol is SMTP, IMAP, or even POP3, right? So we will mention what's the difference between the IMAP and POP3. But generally speaking, S means send, right? In means input or inbox, right? So you can think about that. So one is the sending, one is the retrieving, okay? But we will talk about that in the next several slides. So the email, okay, I think everyone is using the email, especially for nowadays, right? Because we cannot see each other personally every day. So the only way to communicate, not only way, but maybe one of several ways to communicate is based on the email, right? To schedule meeting, to answer question, ask a question, right? So email is very important. And the three major components in the email is a user agent, mail servers, and the protocol, right? It's simple to understand. You have to have some um, application like Microsoft Outlook, like Gmail, like the default mailbox of the iPhone, right? No matter in laptop or in your or smartphone, right? You have to have some agent or or client software, right? So that's something you installed in your end, but that's not the thing to deal with the emails, right? It's just the client or end software. There should be some server, right? The mail server to handle what kind of the emails you received or you sent, right? So there should be a mail server there. Okay, so you have the cell phone, the client agent, and you should have the mail server, right? And finally, you need to have some protocol, right? It's also similar to HTTP client and the server, right? So we repeatedly emphasize client and server diagram. That's very classic and important, right? So here, same thing. Okay, so SMTP represents for the simple mail transfer protocol. Okay, simple mail transfer protocol. So user agent here, just as mentioned, the mail reader, right? You can composing, editing, reading mail message, Outlook, iPhone, mail client, uh, outgoing, incoming message stored on the server, right? So I think I have explained this, right? You have the client on your laptop, iPhone, or smartphone, but ongoing or incoming message has been stored in the or saved in the mail server, right? The mail server handles the send and receive. Okay, so specifically, the mail server contains incoming message for user, and it has a queue, right? Message queue of outgoing to be sent mail message. So if you send the 10 message at the same time, definitely it has a queue, right? To manage the mail, the email you want to, your message you want to be sent out. Okay, so the SMTP protocol between the mail server to send the emails um, and your local clients, right? So the client sending mail server, the server receiving mail server. Okay, so we will use a figure to show how SMTP protocol works between the client and the mail server. Okay, so here is the RFC. So you know every protocol has a RFC, right? Request for comments. It's like a standard, or it's just like it's just a standard, right? So it posted for people to comment, and it defines a protocol. And this is a traditional version of SMTP. It has some upgraded version, right? But we don't want to focus here. Every protocol has its unique RFC number, right? So based on the RFC definition here, the SMTP is to use TCP to reliably transfer email message from client to server using the port 25. Okay, still remember HTTP is the port 80, right? So here's port 25. So I think you should know that why we need to have different port, right? We explained that before. And the direct transfer, sending from the sending server, right, like client to receiving server, okay? And the three phases of transfer. So first, you need to have a handshaking, okay, greeting, and then transfer the message, finally close the connection. So we will show SMTP send and request, similar to HTTP send and request, okay? the procedure. Okay, but this is just a quick standard definition. And the command or response interaction like HTTP, the command is basically text, and it has a status code and the face. Okay, the message must be in 7-bit ASCII. Okay, so that's just a standard definition for the SMTP protocol. And let's see an example for a case that Alice wants to send an email to Bob. Okay, so Alice uses this UA is user agent, right? Or just your Outlook. And I think previously I used Foxmail or something, right? But nowadays I don't see that much. But yes, for example, Foxmail or some client software, right? And Alice used that software to compose an email, writing email and message to Bob, right? The Bob is a username at mail server, right? And Alice client sends a message to her mail server. So first, you need to use the SMTP protocol to manage the agent, your agent, right? Your client uh, and your mail server, right? So for example, if you are using the Google, right, Gmail, right? So the mail server should be the Gmail's mail server, but the receiver's mail server could be Hotmail, right, or just Microsoft Outlooks or some mail server there, right? They are not necessary to be the same. So first, you have to use your client or agent to communicate or send the message to your mail server. Okay, the mail server will queue your messages there. Okay, and the client side of SMTP open TCP connection with Bob's mail server, right? So this is the TCP connection to send your message to Bob's mail client mail server, and Bob's mail server will get the message over the TCP connection. Okay, and finally, Bob's mail server places the message in Bob's mail box. Finally, Bob invokes his user agent to read the message. So here, from 1, 2, 3, right, that would be SMTP because you only need to send the message email, right? But from 5, 6, Bob needs to receive the email. That will not be a SMTP protocol. We will talk about that later. But generally speaking, that's a message retrieving protocol, right? That's not a sending. That's a retrieving. Sending is only between the agent and the mail server, or mail server and the mail server, right? From mail server to your agent, you just retrieve the message. So we will mention that, but that would be a POP3 or IMAP protocol. Okay.
So, on another note, I remember back when I was first introduced to email that there was a send receive button. Is that a forceful sync to the mail server? Considering that, like, somebody could be on a dial-up connection, it may not have the bandwidth to do more than one thing at once.
Sorry, Joseph. I try to understand your question. So you mentioned that when your first time was introduced to email, so you have some button. That button is what?
It's called Send and Receive. It was on a old, I think it's still in Outlook, but I remember having to manually synchronize back in the day.
Okay, that's a very good question. Yes, so we'll talk about that later. So for IMAP protocol, that's a synchronized protocol. That means you have to. I mean, yeah, nowadays you don't need to manually synchronize, but you are right. Sometimes before you, because of bandwidth or something, you don't want to be bothered by email every minute or something. You can do a manual synchronization. That depends on you, right? But nowadays people want to be as synchronized as possible, so you can open that option. But generally speaking, the IMAP protocol is to synchronize your message between your client and the mail server. It's not necessary to always synchronize, right? You can do some periodical synchronize, right? So that's why maybe there is a button you ask the client to synchronize with the mail server. Otherwise, you shouldn't synchronize, right? That's a function. Mhm. Okay, so we will talk about the IMAP later, but here is for the SMTP and for the whole email send and receive procedure, right? And similarly, so here is another figure, right? From a computer lab, from a desktop to SMTP server, right? Here we give you the SMTP server URL, right? Or the server address, right? It's smtp.gmail.com. That's because you are using the Gmail, we assume, right? And send that message from SMTP server to received email server, and the received downloads the email from the email server using POP or IMAP, right? So that's another quick demonstration figure. So so here is a sample SMTP interaction. Let's assume that, so S means server, okay? So C means kinds, okay? So let's say here we want to communicate or send the message to the hamburger.edu, okay? Hamburger.edu. So here's the message or interaction SMTP between the client and server side. So first, mail from. So the text I marked in red are the commands, okay? So the text I marked in blue are status code, okay? So let's go through them one by one. So first, mail from. Mail from is a command, right? It's easy to understand. Just a mail from what, right? So you mail from this Alice at Crepes France, right? That's some mail server, right? You just first um, establish the connection, right? You mail from, and the server will return you a code 250. That's code means that if the sender's email address is accepted, the server will reply with a 250 OK reply code. Okay. After the server replies OK, and the RCPT2, that's a receipt two. That's a command to reply, right? To reply to Bob. Okay. Still return the same status code 250. Okay, the receipt, okay. And after that, they have already established the connection, right? So not only for the mail from, but also the receipt too, right? After these two commands, the connection has been established, right? You talk to, Alice talk to Bob server replies received okay. And then after that, that's a data command, okay? That data command follow that is message or email content itself. The status code, so after the data command has been sent to the server from the client, the server will respond 354 reply code. Okay, so you can think about the 250 is mail from or received to. That means the status is okay, right? Reply is okay, so it's a 250. So after the data, there is a status code 254. That means after the code, you should input some mail contents itself, okay? Blah, 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 from S to client, client to server, right? And after the some data, that would be a dot, means the end of the data, okay? And the server will say the 250 message accepted for delivery. And after that, it's a quit command. Okay, after quit command, it will return a status code 221, and close the connection. Okay, so I don't think you need to remember every status code or the very detail of this interaction. But generally speaking, you should know that similar to HTTP commands, get, update, right? Similarly, there is some interaction or commands here, the mail from, received to, right? And the data and the quit between the client and the server, okay? So I put a reference here. It will give you more commands, but I think generally speaking, this example is good for you to understand how SMTP interaction, right? From client to server and server back to client and close the message and quit, okay? So that's a quick example. So let's try to compare the SMTP and HTTP, right? So for HTTP, it's client try to pull some message or get some message, right, from the server. But for SMTP, it's try to push, right? You try to send your email, you push your message from client to server, okay? Both of the protocol have ASCII command response interaction status codes, as I mentioned, right? Different status codes, but similarly, right? And the HTTP, each object's encapsulated in its own response message. And the SMTP is a multiple objects sent in multiple messages. That's one difference, okay? And next is SMTP uses persistent connection. As we mentioned, HTTP can have the persistent version or non-persistent version, right? But SMTP use persistent connection. That means you open the connection, you can do multiple thing, okay? Not only one object for one time, okay? So it's use persistent connection. And SMTP requires message head body to be in 7-bit ASCII. Okay, so the 7-bit is a 128 symbols. Okay, so you can find what kind of the 128 symbols in the SMTP protocol. There would be a table there. Okay, but generally speaking, it needs to be in a 7-bit ASCII. And the SMTP server uh, I think it's dot, right, to determine the end of the message. So here, so in this line, right, to determine the end of the message or the data, okay? So that's a simple comparison between SMTP and HTTP. So similar to HTTP message format, we can also have a mail message format. I think this much easier or simpler than the HTTP format. So HTTP format, still remember, we have some different headlines, right? And we have to have the HTTP version or some different information there. But for the mail message format, it's kind of just you have the head files, you have the to, from, subject, right? It's very similar to what you are using in the email, okay? And then that would be a blank line, okay? And this line is with the body of the email message area different from SMTP mail from receive to commands, okay? This is just as a, like a HTML format, right? This is just like a headline you put into the mail message format. It's not like a SMTP mail interaction, okay? And the body is the message, ASCII character only. So I don't think the mail message format is complicated. You just need to give the receipt address and the subject and your address, right? And the body of the content. That's all. And SMTP interaction will handle the following um, message sending to from your client to the server. Okay. So we talk about SMTP, but as I mentioned, that's only something you sending the messages, right? Uh, Sending message cannot be the only part of the email service, because you can send, but you also need to read the message. So here, besides the SMTP, we also have IMAP, okay, or POP3. So SMTP is the deliver and storage of email message to receiver server, right? So until here, right? So previous steps are using SMTP, as I mentioned, from agent to server, server to server, okay? But after that, you have to use something to retrieve your message in the server. So we have the IMAP. So IMAP is the Internet Mail Access Protocol. The message is stored on the server. IMAP provides retrieval, deletion, folders, or stored message on server. So let me give you more information here. So someone may notice that in your client software, for example, I believe in your iPhone mailbox, right? Or the Firefox. I'm not sure Outlook, but I believe Outlook can do that. But generally speaking, now we are just logging to the Microsoft account and do that, right? But if you don't use that function, you just configure the sending and receiving server by yourself, you will find that there was a address you can put, right, for the incoming and outgoing server. I think like this, okay? So you can first put your username and mail address, and you should specify the server information, incoming server or outgoing server. Outgoing server is just like smtp.google.com or .gmail.com, right? That's what we have already mentioned. But for the incoming mail server, so that's the last step, right? You want to retrieve or receiving the message from the server itself. And we can use different protocol. Popular tools are POP3 and IMAP. Okay, so POP3 is a protocol to downloading the email from your mail server to your local device. After the downloading, the email would be deleted in the server. Okay, that's the most important concept you need to remember. So POP3 is not quite synchronized. Okay, it's just download the message from your server, and the server will remove that message or that email. But I think some students may ask, okay, using the POP3, I can still find that if I download something, the mail still there. That's because the server could provide you an optional choice to keep a copy. But for the POP3 protocol itself, after download the message, the mail should be deleted. And for the different device, for example, if you use um, laptop and the iPhone or smartphone, right? That two devices may not be synchronized. Okay, so this mail could download, this device could download this email, that device could download that email. They are not in the exact same structure. So what do I mean for structure? So for example, if you have Outlook in your cell phone, if you have you have a laptop, right? If you are using the SMTP, you can find the structure, inbox, junk, the trash, delete, everything are exactly the same, okay? Because they are synchronized if you are using the IMAP. But if you are using POP3, okay, that may not be necessary to be the same. You can use this form to download that message and delete that message in the server. It will automatically delete in server if you don't use that option. And then your laptop may not be receiving that message, right? They are not in the synchronized status. But but I mean, different protocols have different advantage. For POP3, definitely you can save a lot of storage for the server. But the bad thing, just I mentioned, they're not synchronized. Sometimes you may miss the message if your laptop download, but you cannot find in your cell phone, right? That's not good. My personal choice is IMAP is good because I don't need to worry about the storage for the server, right? I just want to every device to be the same. Okay, when I send a message in my laptop, I can see my I might send a message in my cell phone. Every place is synchronized. Okay, so that's a simple, quick explanation of IMAP and POP3 here. I didn't put POP3 text here, but just give you more information. Okay, and that's SMTP and IMAP, okay, protocols for sending and receiving the message. And also people may choose to do not use a client, use an agent or client software, right? They can just log into the web to write or send or receive the message, right? And HTTP now provide a web-based interface on top of SMTP send and the IMAP to retrieve your message. You just use the HTTP as another application layer protocol, right? Sitting on top of the IMAP and the SMTP. So, but the principle is similar, right? To send and receive the email. Okay. So I think that's content for the email, SMTP, and IMAP. I don't want to go to the next DNS in this lecture, so we can do that next lecture. But I think for DNS, it's not difficult. I mean, everyone is using that every day, right? It's just a domain name system, right? To manage that IP and your domain name, right? You don't need to specify the IP address because I don't believe you can remember all the IP address for the different web service, right? So it's a long number series, but domain name is easy to understand. So next lecture we can do that. So any question for the email, SMTP, or even web and HTTP? So that protocol, those protocols and the application. Okay, so oh, by the way, so if I may not be always in the Zoom link for my office hour, if you find I'm not there, just feel free to send me a quick message. I will log in, okay? Because I close the uh, automatic notification, okay? So if someone going to that uh, Zoom Zoom meeting room. Okay, so because if I open that, when you log into the classroom, I will receive a lot of message. But just feel free to let me know you are in the that meeting. Okay, so I will go there. Okay, so if no question, okay, that's it for today. So maybe for the next lecture, let's try to finish more topics, the DNS and the P2P application, and let's try to wrap up application layer maybe next week. Okay, we spend 2 weeks for the application layer because this is very important. And I will post another assignment later. And also the example answer for the assignment 1, okay? So I will also ask the TA to grade and hopefully he can finish the grading within this week or early next week and post the grades, okay? Any question, just send me a message or leave me a message. Okay, thank you everyone. Thank you for attending. So see you on Friday. Okay, have a good day.
Thank you.
Thank you.
Goodbye.
Bye.